Okay, this is lesson 78, exponents and square roots. So, we know that multiplication is repeated addition. 3 plus 3 plus 3 plus 3. Let's do 4 threes. Is the same as 4 times 3, right? It's all 12. Exponents are what you use to show repeated multiplication. So if I say 5 times 5 times 5, that's the same as 5 with the little tiny 3 up high and behind the 5. So that's called an exponent. The 5 is my base, and the whole thing all together is my power, okay? So let's multiply. 5 times 5, I get 25, times another 5. So what's 5 times 25? Can you do that in your head? I don't know that I can do that in my head. 25 times 5. 5, carry the 2, that's 10, 125. So I know that 5 cubed, or 5 to the third power, is the same thing as 125. Does that make sense? Okay, so how do you say that? Did you hear me? I just said 5 to the third power, and before I said 5 cubed. You can say it either way. Normally, 3 to the second power is 3 squared. 3 to the third power is 3 cubed. And then you start just saying 3 to the fourth power, 3 to the fifth power, whatever. So what does that even mean? Squared. Let's go with squared. So I have a square, right? And it is 3 units on each side. It's 3 units long and 3 units wide. And I know to find the area, I multiply length times width, right? 3 times 3. So 3 squared is 9 square units. 3 times 3. And if I count, I'll see that I have 9 littler squares inside. So 3 squared is 9. When you're talking about inches, if those were all in inches, then I would have 9 square inches. Before, when we were talking about area, I think we were talking about floor tiles. So if that had been 3 feet each, you would buy 9 square floor tiles. Okay. So think about multiplication. 3 groups of 3, right? 3 times 3. So I have 3 rows, and there are 3 in each row. All right, enough of that. This is going to be a long one, sorry. Okay, example 1, they want you to know more about cubic stuff, so 3 to the third power. So I drew a little bit of a lopsided cube. And if you look at that, I have 9 little squares in this first row, and then I move back in the pink row, and I have 9 squares, and I move back again to the blue row, and I have 9 squares. So I have 9 plus 9 plus 9, or 27. So 3 times 3, that gives me the 9, times my 3 rows, and that gives me the 27. So I have 27 cubic units. So each of these little things is a cube. It's not just flat. So if things are cubic, they're in 3 dimensions. Floor tiles are flat, so those are squares, right? They don't stick up and they're not cubes. These are all little cubes. So that's where you get that 3 cubed. So there are 3 groups of 3 each, and there are 3 of those. So it kind of looks like a Rubik's Cube, doesn't it? Okay. Example 2. This one's a little tricky. I don't know if you've done this or not. If 2n equals 6, then what does n squared equal? So if you have a number bumped up against a variable or a letter, and there's nothing in between, so we call that the coefficient, and that's the variable. So it's a number and a letter. If you bump them up together, that means you're going to multiply them. So that 2n is the same thing as 2 times n. So let's look at it written this way. 2 times something, we don't know what yet, equals 6. When you think about it that way, you know that 2 times 3 equals 6, right? It's my favorite problem in the whole world. You can use this, if you go back to that problem, you can solve a lot of stuff and then get the same idea to solve other things, harder things. Anyway, n equals 3. But that's not what they asked, was it? they ask what n square is. So n square would be 3 times 3, right, is 9. So 3 squared is 9. Okay, example 3, they're talking about powers of 10. So remember what a power is. Get my paper back. So the power is the whole thing, right? The base and the exponent together. So if I have powers of 10, I'm talking about the base of 10 and then the exponent. So 10 to the first power is just 10. It means I don't have any other 10s to multiply it by. 10 to the second power is 10 times 10, that's 100. 10 to the third power, or 10 squared and 10 cubed, 10 times 10 times 10 is 1,000. 10 to the fourth power, 2, 3, 4, 4 tens is 10,000. What do you notice? I kind of highlighted this. So see how there's 1 0 in 10 and your exponent is 1? See how there's 2, your exponent is 2 and you have 2 zeros? 3 zeros, your exponent is 3. 4 zeros, your exponent is 4. So that kind of makes sense, doesn't it? So if you ever get confused, count your zeros. Something they pointed out, and this is kind of handy, is 10 to the 0th power is just 1. Anything to the 0th power is just 1. Just something handy to remember. Okay, example 4. They said write 4,500,000 in expanded notation using powers of 10. Okay, so first I'm going to write it just in regular expanded notation. So 4 times a million plus 5 times 100,000, right? So I know altogether that would equal 4,500,000. But if I wanted to write this million in notation, so using powers of 10, I count my zeros. I see I have 6 zeros, so it's 10 to the 6th power. I count my zeros, and it's 5, so 5 times 10 to the 5th power. Pretty easy, huh? Okay, they kind of threw exponents and square roots in the same lesson because they're related. So one you're building up, the other you're tearing down a little bit. So square roots, you're kind of finding pieces of things. So let's say I have a square and it has 25 little square units inside of it. So I know the area is 25 square units. They want to know what the length of each side is. Well, since it's a square, I know that each side is the same length. So the length and the width are going to be the same number because it's a square. So I know that something times itself equals 25. So something times something, 5 times 5. Good. So 5 is the square root of 25. And all that's saying is, can I find one of the factors, or the length of the side of a square? And it would also be the width of the side of a square. Right? Okay, let's look at example 5. A square has an area of 36 square centimeters. So they didn't draw this out for us. So they want to know how long each side is. Oops. So again, you know both sides are the same length. So 36 equals something times the same thing. So 6 times 6, right? So that I know each side of my square, even though I didn't draw it out, is 6 centimeters long. If I drew a square with 6 centimeters long and 6 centimeters wide, it would have 36 little square units inside, right? This one's centimeters, so each would be a square centimeter inside. All right? Hadn't learned this yet, but this is the square root symbol. It's kind of a little short thing, so almost like a check mark, and then you put like a line on the outside of it like that. So that's the symbol. So if they say find the square root of 36, you could write it this way: the square root of 36 centimeters. And now that you know it's 6 centimeters. Okay, so the 6 is the square root of 36. I'm sorry, 6 is the square root of, 36. Second guess myself. Example 6, same idea. Find the square root of 100. Something times itself equals 100. Well, it's 10 times 10, right? So 10 times 10 is 100. So 10 squared equals 100. That's easy. Once you get the hang of this, it's pretty easy. Gets a little harder when you don't have a perfect square, but luckily we don't have to worry about that yet. Let's pause and talk about perfect squares. So I'm going to come down here. Perfect squares. So that means it's whole numbers. It's not parts of numbers. So 1 times 1 equals 1. So the square root of 1 equals 1. 2 times 2 equals 4. So the square root of 4 equals 2. I'm going to skip some. 6 times 6 equals 36. So the square root of 36 equals 6. 8 times 8 equals 64. So the square root of 64 equals 8. You get the idea? So you could go on and make a nice list. And sometimes that's a handy thing to have, a list of the perfect squares. If you're good with your multiplication tables, you probably don't need that. But if you're not, you might want to make a list. All right, let's go back up to example 7. They said compare the square root of 9 plus 16 and the square root of 9 plus the square root of 16. Looks like it ought to be the same, doesn't it? Well, let's simplify. We're going to do this stuff under the square root sign first. Nothing to do there, nothing to do there, but we can add those. So 9 plus 16 is 25. So when I simplify, I'm going to write my problem again and make it simpler each time. That whole writing your problem out a couple of times is so hard for kids. I don't know why. It was hard for me when I was a kid. But boy, if you write it out every time, you don't make mistakes. So, simplified square root of 25 is greater than, less than, or equal to square root of 9 plus the square root of 16. Okay, well now let's simplify. Let's find the square root of 25. So, something times itself. Good, 5. Okay, square root of 9. 3 times 3, right? So 3 is the square root of 9. Square root of 16, 4, right? So now I see that 5 is greater than, less than, or equal to 3 plus 4. Well, let's simplify again. 5 is less than 7. So you know that little tiny end points to the smaller number. The bigger side points to the bigger number. And I have my lesson. Okay, practice this stuff. Use your symbols correctly and use the right words. All right, good luck.